This problem says the function f of x is equal to 3x plus 3x to the negative 1 has one local minimum and one local maximum. This function has a local minimum at x equals with value and a local maximum and minimum at a value of x with a function value. We need to fill in those blanks. So first of all, to find local mins and local max, we need to find the critical points. And the critical points are where the derivative, the first derivative, is equal to 0. So we need to start by finding our first derivative. The derivative of 3x is 3, and the derivative of 3x to the negative 1 is minus 3x. Subtract 1 from the exponent to make that negative 2. So we set this equal to 0, and let's move our negative term over to the right hand side by adding it on both sides to get 3 is equal to 3x to the negative 2. Now let's make our exponent positive by putting it in the denominator and make it 3 is equal to 3 over x squared. Then we can multiply both sides by x squared to move the x into the numerator to get 3x squared is equal to 3. Then divide both sides by 3, and we get x squared is equal to 1. Take the square root of both sides, and that gives us x is equal to plus or minus 1. So our two critical points are positive and negative 1. So let's draw ourselves a number line and label negative 1 and positive 1. We need to test and see what happens to the derivative in between these regions. So let's set up if this is our derivative, we need to find if it's positive or negative, because that'll tell us if our function is increasing or decreasing. So let's pick a number to the left of negative 1 is negative 2, and then 0 would be in the middle. To the right of 1 would be positive 2. So these will be our test points to find what's happening, what the derivative is doing in the regions that are not at our critical points. So the first derivative at negative 2 is 3 minus 3 times negative 2 to the power of negative 2. So this makes 3 minus, this would be 3 over positive 4. And 3 minus 3/4 is a positive. So this would be a positive here. And then let's find f prime of 0 would be 3 minus 0 to the power of negative 2. But that makes that makes a 0 in the denominator. I left off my 3. But that's not a good thing to use. Actually, we should probably make that a critical point, actually, because that makes the denominator go to 0. So let's not use 0. Let's actually use a number to the right and left of 0. Let's use negative 0.5 and positive 0.5. Because the derivative doesn't exist at 0, since that makes division by 0. So let's come over here and do the first derivative at negative 0.5 is equal to 3 minus 3 times negative 0.5 to the power of negative 2. So that would be 3 minus 3 times 0.5 to the power of negative 2 would be 1/2 with a negative exponent, which would make 1 over 4. And if you flip it, then it would make times positive 4. So this would be 3 minus 12, which is a negative number. So this will be a negative here. And then for positive 0.5, f prime of positive 0.5 would be the same thing, would still be a negative. So this will be a negative here. And then f prime of 2 is 3 minus 3 times 2 to the negative 2, which is 3 minus, this makes 1/4, so 3/4, and again that would be a positive here. Okay, so what's happening here is we're increasing until we get to -1, so we'll increase, and then once we get to on the right side of -1, we're going to decrease. So this will be a max. If we increase and then decrease, that makes a maximum. So our maximum is x is equal to -1, and our function value at -1, we still need to find that. And then here we have the function decreases and then increases, so this would be a minimum. So we have our minimum is at x is equal to 1. But now to find those values, we need to plug them back into the original function. So let's find what f of -1 is. F of -1 is 3 times -1, oops, that should be a 1, plus 3 times -1 to the power of -1, which is -3. This would just be a -1, so it would be -3, which would be -6. So at -1, that's our maximum, which is at -6. And then for f of 1 is 3 times +1 plus 3 times +1 to the -1, which is just 1. So this would make 3 plus 3, which is +6. So it might look a little strange that our maximum is lower than our minimum, but we can graph it on a calculator to verify that that is accurate. I won't do that at this moment, but I will check it when I finish this video and leave a little note in the comments. So I hope this was helpful for you, and if it was, please subscribe to my channel and click on the little bell so that you know when I make a new video. Thanks.